Oh, doing great, doing great. I just need to, I'm just waiting just a second. It says I need to pause recording audio and the presenter screen. Right, I pause that. Now I'll start it again and let's see what happens this time. Okay. I think we're good now. All right. So let me go through and we'll do the introductions and then we'll turn things over. I promise I won't take too long because people would rather hear you than me. As always on the DB2Night show, we have our social networking things. This is your show. Make sure you check Twitter out and make sure you subscribe to our hashtag of DB2Night so you get notifications on shows as they come by. We have our LinkedIn group, and we also have our replays available on YouTube, so you don't have to download anything should you'd like to listen to the replay that way. And Sheikh, I'll be asking you for your PDF of your slides if you don't mind. We'll share those with the audience as well on our replay blog.
Absolutely.
Here's our standard disclaimer. We have copyrights. We will make things available, etc., etc. There we go. And today shows the announcements. The upcoming shows we have are on DB2 LUW. Carrie Romanoff will be joining us in January to talk about DB2 11.5.5.5. And maybe had too many .5s in there. Sorry about that. And the next show in February will be Michael Tiefenbacher from Germany talking about iterations over recursion. And I've seen this presentation and I asked him to speak, he offered this presentation. And I think it's a really good presentation and I'm looking forward to having him share that with the DB2Night show. It's really worth seeing. On the Z side, we'll have Roy Boxwell speaking on January 29th from Segas. Roy is a great speaker. And he'll be talking about things that are deprecated in DB2. And on February 26th, tuning SQL that still works, and I forgot to put the name, it's Cheryl Larson of BMC. So we've got a star-studded lineup for our Z shows coming in the new year. And I will have those shows available for registration, hopefully by the end of the weekend, so you'll be able to sign up and we'll be able to send you reminders when the shows are coming. As always, DBI, our founding sponsor of the DB2Night show, is interested in having you watch their seminar on tuning DB2 LUW in minutes. And that video is available, and there's a download, and they ask for your information so they can send you a gift card should you watch the demo. Last week's winner was Bob Jackson of the Unum Group. He's getting himself a gift certificate. Thanks for watching, Bob, and it pays to watch the DB2Night show. What can I say? And here are the sponsors of the DB2Night show again, DBI, and yours truly, Martin Hubel Consulting, Inc. And before we get along, I thought I'd put in yet another piece of humor. This one is, I just got my Christmas tree from IKEA. I think it's going to be a long night. IKEA's, unfortunately, some things require a little bit of assembly before you can actually use them. So there's my Christmas tree. And while I'm working away, I know that Charlie, the co-host of the DB2Night show, will be doing what he always does. He'll be sleeping, but of course, he won't be wanting to see what I'm doing, so he'll be hiding his face. Yes, it will be a long night. All right, now we're into our pollings. Our studio audience polls, as always. Get ready to vote and tell us what you're doing. And here's the launch of the, what versions of DB2 LUW are you currently running? You're getting the responses on that and getting people to vote. And we're getting near that critical time. We've got enough people voted. So I'll close the poll and share their result. Still people running some old code, but we've got more and more people on 11.5, and that's great news. And the next poll is, these are next ones are show related. What's the typical size of your machine learning data sets? And getting some votes here. We're still waiting to hear a few more from our good-looking studio audience. There we go. And with that, I'll close that off and share the results. And looks like people that are doing it big. That's probably a very good thing. And our next and last question for this segment of the show. Oops, I've got two more questions. I'm sorry. What's the most frequent machine learning use case? And, sometimes the DBAs are involved in this, and sometimes it's other people. Other people are doing the data science work. So we might get some answers here. And what we're seeing right now, I'll close that and share the results. It's about 50-50 between the people doing it, classification and regression. Hide that and do the last question in this thing, which is the biggest challenge. What's the biggest challenge faced on a data science project? There'll be votes coming through on that, I hope. Maybe takes a little more thought, this one. We've got about enough votes on that, so we'll share the results. And people say the biggest challenges are data quality and data volume. Interesting. Okay, so what I'll do is hide that, and I'm through all the things I need to do. So Sheikh, I'll be turning it over to you now. So here we go. I'll make you the presenter. And as I said earlier, we'll be, I see your screen, and so it's all you. I'll be muting myself, but I'll break in with any questions that come through, and we'll look forward, and I'll just let you take it away. Thanks.
Martin, do you see this in full screen mode?
I see your screen. It looks marvelous.
Okay, wonderful.
You're in great shape.
Okay. Good morning, everyone. My name is Sheikh Kader. So today I will take you through the machine learning capabilities in IBM Db2. And now, before we go too far, let's talk about why we are talking about machine learning. Since I'm part of a database product, IBM Db2, so why machine learning is relevant to us. As you can see from this survey number, so majority of the machine learning data sets in the enterprise setup are coming from relational sources. So which means that we have a lot of opportunity to partner. As a database product, we have opportunity to partner with the data science teams to help accomplish the machine learning or achieving the machine learning goal. So let's look into some of the specific opportunities. So we all know, I would imagine that most of us are familiar with this kind of workflow of a machine learning process in an enterprise setup. So typically this starts with here, that the data is stored in a database such as IBM Db2. Then a data scientist would take a sample of the data, move this to a separate development system. It could be their laptop or maybe Watson Studio or Jupyter Notebook, so a separate dev system. Now this data scientist would iteratively try, define hypothesis, define algorithm, pre-processing steps, feature engineering, and at some point they would be comfortable with the outcome of the model training. So in this process, they also work with a business SME. The business SME is the person who has the knowledge of the business and then also understand the data, and data scientist has the skills with using the toolkit, like they know the algorithm, they know different machine learning tools. So together they come up with a machine learning model. And so this whole process on the left, this is basically the model development phase. And there are many challenges that come in this phase. So the top 3 challenges, as I see here, the regulated data. So essentially, it means that you have very sensitive data that are under some regulations like GDPR, CCPA, etc. So if you are to copy that data from the source to separate system, so you have to make sure your data is being governed, so that you are fully compliant with the regulated data. So this is one of the major challenges when you're dealing with regulated data in your machine learning project. Excuse me. Other challenge is the data volume. Let's say you are looking at large volume of data. So let's see that we see that most of the people in the poll, they say their data size is roughly more than 25 gigabyte. Now, if you look into a typical MacBook, which is shipped with 16 gigabyte of memory. So right there, you will not be able to bring all the data to your laptop's memory. So how do you deal with the large volume of data? And we all know that in today's measure, gigabytes is not considered a big data. If you're looking into big data, that's mean you're looking at hundreds of gigs or terabyte. So data volume keeps growing. So that's another challenge. How can a data scientist with their limited computational resources deal with a large data set, build good model? And finally, one of the major challenges, probably the most difficult challenge, is the noisy data. So 25% of the data are noisy. This came from some surveys conducted in the US. So which means if you are building machine learning model with using the noisy data, let's say that is has 25% noise. So right there, this model is going to inherit that noise. So that will means that the quality of the model will suffer. So these are the challenges that are related to the ML development. Now, if you manage to address those challenges, or at some point you have a decent model, now a new set of challenges emerge, which is related to the ML deployment. So you have a model which you have trained somehow, and you have a decent performance of that model. Now you need to deploy that model somewhere so that any applications or any users, they can consume the predictions or the outcome of that machine learning model. So just not your developing model, you also need to serve the applications and the users with that model, so they can use the model for real-time insight. Now, the other thing, so basically there are challenges with hosting of the model. Second category of challenge is speed. So you have think that you are building a machine learning models for payment processing, for example. So that means every time there is a credit card transaction, and all these transactions need to go through a machine learning model and get a clearance whether this transaction is valid or fraudulent. So in a very busy setup, there could be thousands of transactions coming up, and all this needs to go through a machine learning model, and the model will come up with a decision whether this transaction is valid or fraudulent. So as you can imagine, where every millisecond is important, because there are people waiting in the line. If you go to Costco, there are big lineup, and there are many locations of Costco. All the customers, they're swiping their credit card. So every millisecond is important here. And now if your data is a one location, which is the database, and your model is deployed in a separate location, is another system. So every time you need to get a predictions, that means your model needs to be so your data needs to be read from the database and sent to a separate system. So that means there is going to be network latency for every scoring or inferencing request. So that is going to bring some challenge. So finally, how can we make it super easy for downstream applications to consume the predictions from machine learning model? So due to these challenges, we see that 51% of the AI projects, they don't go beyond experimenting because they don't have a clear path or easy way of deploying the model, achieving the speed and integration. So in IBM Db2, our philosophy has been this, that the customers, Db2 customer, they're storing data in Db2, and typically if they just follow the typical process, they would be retrieving the data, move it elsewhere. And now, how can we help a data science project or a data science machine learning practitioner with addressing these challenges, be their partner in addressing these challenges in whatever scale we can, so that the data science projects and data scientists, they are more productive and they have a better solution in addressing challenges related to ML development and also ML deployment. So today I will present to you two categories of solutions we have in IBM Db2 that deal with these challenges, or some of these challenges that I have highlighted a little ago. So the first category of solutions we have in IBM Db2, here it is integrating open source models with Db2. So we recognize that the open source community for machine learning is very vibrant. We have a very rich open source community. There are plenty of frameworks, sikit-learn, TensorFlow, Keras, R. So there are many popular frameworks, and they have got a rich ecosystem. There is a rich adoption there. So we, how can we support those open source models with Db2? So we do have some solutions. I'll take you through those. That's basically the first idea, that you can use open source toolkit or ecosystem for constructing and training your model. Then you can integrate with Db2. And the second solution we provide is you can build your end-to-end machine learning workflow entirely inside Db2 without ever moving data, the raw data, outside of the database. So that's the second category of solution we have. Now, let's go deeper into the first type, which is bring your open source models to Db2. So I looked into a research publication recently. So there has been a 10-year prediction of enterprise-grade machine learning. So based on different research and the industry trend, so the authors of this paper, they have suggested that the future is that people or the data scientists or machine learning practitioners, they will be training their model anywhere they want, using any framework they like. So it can be in cloud, it can be their laptop, any system. But eventually, once they have the finished product, which is the machine learning model, they will use score or use that model closer to the data, which basically means, in our case, on the database platform, to for different benefits that I will expand soon. So now let's look into certain use cases for in-database scoring. So I already given one example little ago, such as latency sensitive in-transaction scoring. So you have every single, you have volumes of transactions coming up in every minute, so you need instantaneous predictions. Payment processing, fraud detection, loan, claim approval, there are plenty of examples like that. And other category of use case for in-database scoring is large batch predictions. What does it mean? Anomaly detection. So if I put a real example from a past machine learning project I led a couple of years ago within IBM. So the idea is that, as you know, that IBM is a big company. We have many products. So what we have done, we have developed a machine learning solution for our internal consumption, where every day in near real time, we monitor all the support tickets that are open. So for example, DB2, so we see that, okay, there are a few hundred support tickets, for example, are open today. And then we have a machine learning process that is monitoring all the activities of the support tickets, the customers' comments. So there is some sentiment analysis happening. So all this needs to be in real time. And then the owner of DB2 product can go to a dashboard and can, in near real time, can see the trend. Okay, how is the emotional trend, sentiment trend, and the customer's sentiment trend is going on, progressing as the day progresses. So as you can imagine, there could be hundreds of support tickets, and there is not only one product. So if you look into IBM, so there are many products. So that means to get a near real-time insight, we need to analyze the entire life cycle of every single support tickets, and there are hundreds of them. And in near real time, we need to analyze this and then come up with some anomaly detection or some prediction that what is the trend, right? So this is just one example I have shared from IBM, but this is, you will find similar example in across the industries. The point I'm trying to make that when your machine learning process needs a large volume of data to get near real-time predictions using the operational data, so moving the data to a separate system will be very expensive and it will be a slow process. So these kind of use cases will benefit from scoring or inferencing machine learning models in the database. So in IBM Db2, we have a solution called Python UDF. What it allows, you can go to Watson Studio, or you can go to open source like Jupyter. You can use Jupyter Notebook, right? You can develop your machine learning pipeline using sikit-learn, for example. Once you have run different experiments, and then you have settled on a pipeline, you can execute that pipeline, and that pipeline is going to produce a machine learning model, which you can export as a job-lib or pickle file, the model object and the scoring pipeline object. You can copy that over to the DB2 server, and in DB2 we provide Python UDF or user-defined function. You can create a UDF, and then you can link that model with the DB2. So next time a customer or a downstream application needs to use that model for predicting, all they need to do is send a SQL query statement. So let me show you. Yeah, so all they will do, the client application or downstream application will send a inference request in form of a SQL query, which will now invoke that UDF, and then UDF will retrieve all the necessary records from the DB2. Then it will reprocess and run by the model to get a prediction and return the predictions. So this will actually provide you an infrastructure for deploying your model. It will cut down the latency because there is no data movement between systems, data and the model co-located, and it can also handle high throughput thanks to the capability of DB2, because in DB2 the query processing is highly parallelized, and it can also go across multiple data partitions. And finally, the other advantage will be the simpler integration. If your model was hosted in some other place, you would have to write maybe some REST API call, and you'd have to retrieve your regular data from a database data source, and then have to get the predictions from another system using some REST API call. Then you'll have to merge those data. But now you can send a SQL query statement to DB2. You can get both ML and non-ML insights from the same source, which is the database, which greatly simplifies the integration. Now let's look into some of the numbers. So what we have done, we have created two equivalent deployment scenarios, and then the first scenario was that our model and the data are in two different places. Data is stored in DB2, model is deployed on a separate system. And we have trained a logistic regression model. So that was the first scenario. And the second scenario is model and the data are co-located, same system, no network latency. And then we trained a logistic regression model using scikit-learn. And then we picked a batch scoring scenario, which involved 800,000 rows. So when we have scored this 800,000 rows using the first deployment scenario, our model and the data are in two different places. So in order, when we have retrieved the data, scored the data using the model on separate system and returned the predictions back to DB2, so it took 1 minute and 47 seconds. When we move the model to the database system, we are able to reduce that time to 21 seconds. So it's about 5 times acceleration. Okay, so this might be a good way to break. Martin, if you wanted to play something, I think.
Okay, thanks for that. Let me just take back control here so I can do what I need to do. And I'll make myself a presenter. And I will, at this point, show this video. So you should see a video coming up on your screen just now.
Hi everyone, thank you for coming to watch the DB2Night show. Today I'm going to show you the new DBI web suite. I'm going to show you just the part about dashboards, make it short. So when you log on to the tool, you would see a dashboard. The dashboard shows you information about all the databases that you are currently monitoring. As you can see here, I have 6 databases installed on one database, on one instance, in one server. You can see here the DBI score that we calculate for each database. The higher the score, the better performing your database is. So you can very quickly see I have a very low score, very high score, and on average, I am doing okay, I guess. I have worst performing databases, best performing databases. I have the highest transaction rates, CPU, memory, and so on. I can dive into any of those databases and look at things in detail. This seems to be low, so I go in there. And now I can see the dashboard for that database. I can see different metrics. I have a timeline here that I can move around and look at different times. I can make the window smaller or larger, so I can look at things in more detail. I can also take any of those charts. I can see here you have CPU usage for percentage busy, percentage by the user, memory usage, memory free, and so on. So I can also go and dive when I see some odd things. I can go and dive into the data more and see things in more detail. Let me take something more interesting maybe here. So you can see here at the top, you can see any changes on the chart. When you hover over any of those points, you can also see if there are any changes. You can see all the changes listed. It tells you that something have changed in the database. You can see the different metrics, and you can zoom in, zoom out, and see any patterns that look odd, like in here, this looks odd. So you can investigate, click on it and investigate it some more. You can add a lot more metrics. You can go in here and choose any metrics you would like, and these will be added to the chart automatically. And so you can compare them to each other in a very nice and concise way. And so this will help you detect patterns and then go in and look at the statistics. Next time, we'll show you more details how to look at the statistics and tune the database. Thank you for watching.
Okay, I'll show my screen here, and thanks for watching that. Helps to pay our bills of keeping the DB2Night show on, and with that, we'll carry on. Sheikh, I will make you the presenter again. You should have that little click box on your screen, and we see your slide.
Full screen mode, right? Okay.
Yep, build and deploy ML models inside the database.
Wonderful. Let's do a quick recap. So far, what we have discussed, we have looked into the how can DB2 integrate the open source model. So now I'm going to take you through our second category of solutions, which allow you to build, deploy, and use your model entirely inside the database. No need to move the raw data between systems. Let's see, how does it work? So in DB2 11.5.4, we do have this set of machine learning capabilities. These can help you create your end-to-end machine learning workflow entirely inside the database. So you can actually do data exploration. So we have we provide a stored procedure to get a statistical summary, and then you can also do feature selection, and there are some other data frame type of operations, so you can analyze your data set. After that, once you found your data set or data set you would like to use in your machine learning model building, we also provide standard data pre-processing capabilities, such as dealing with missing values, normalizing your numerical values, standardization, discretization, and then you can also do train test split of your data set. Model training, we support both supervised and unsupervised machine learning use cases. So for supervised machine learning, we do have decision trees and naive Bayes for training of classifiers. We offer linear regression for regression modeling. As for unsupervised machine learning, we offer k-means clustering algorithm and also association rules mining algorithm. And we also provide the model evaluation capabilities for each of these model types. Once the model has been created, the model is automatically deployed inside the database using the InDB, and then you can use it using DB2's prediction stored procedure. And also we already looked into the Python idiot capability. And all the algorithms that are in DB2, these are distributed, which means if you have your data in multiple partitions, and then you want to train a machine learning model such as decision trees, then this learning will be distributed across all the data partitions. And as the outcome of the learning, you will have a single model which has been learned from all your data partitions. So this is very helpful to leverage the compute resources of different database nodes, while not required to moving all the data to a single compute node and do the computation. So this helps you to deal with scalability as well as the resource issues to deal with large data set. And also this model, it does not require you to move the data to other systems. That's mean you're not copying you're not making multiple copies of your data, which will make your life a lot easier to be compliant with different regulations such as GDPR, etc. Since you're not making multiple copies. Now, we already talked about this, the distributed model training. So all DB2's native machine learning algorithms are distributed by nature. So let's talk about some real use case. So this is from IBM sales team. So they are using DB2 product and the DB2's machine learning capabilities to implement their machine learning use case. So what's the use case? The sales team, they work with different customers and then recommend them products that are most suitable for them based on their historical purchases or the products that they're currently using, their characteristics. So based on these, so for this implementing this use case, that IBM sales team, they have used the k-means algorithm, k-means clustering algorithm from DB2 to segment the customers, and then in order to find the product recommendations, they're using the association rules mining algorithm. Now, time for a demo. Let me stop sharing and I'll switch to the demo screen. Martin, can you please confirm that you are able to see my browser?
Yes, linear regression with IBM Db2 stored procedures.
Yes, wonderful. 1 second. So this is the this outcome came from a Jupyter notebook. I'm not executing this slide, but this is from a real notebook. So here we'll be training a linear regression model inside DB2 using DB2's native ML stored procedures. So this in the single notebook, a machine learning model is built, trained, and deployed. What is the machine learning task here? So we have some customer data. These are not real data. This is some data that is not based on the real customer data, some artificial data, where we have some information about the customers, what is the age of the customer, their gender, and some of the additional demographic information. And then when they have visited certain store, what products they have purchased and how much they have spent. So based on this data, we are here training a machine learning model that will learn to predict the purchase amount for a new customer. So for a new customer, so we just have their input information, but we don't know their purchase amount. But this machine learning model will help us predict the purchase amount. So how do we build this model? So first, I'm not going to go through every single cell, but I will kind of highlight the major capabilities in this notebook, and also the complete notebook, and how you can try this on your own. It's available in DB2 sample Git repository. So once Martin uploads the presentation deck, which will have link, so if you want to try out the demo on your own. So first of all, so here we make a connection. By the way, this notebook can be executed anywhere. You can execute this in your laptop, you can execute this in Watson Studio or any system, and you can as you interact or with this notebook, so all the stored procedure calls being pushed in the DB2, and it's executed virtually on the DB2 system, and you see the output. So there is no data movement, but you can actually use your own system for building this notebook. So DB2 comes with a Python driver. So using that Python driver, so we are making a connection to the DB2 system where our data is stored. Okay, so let's see. So DB2 provides a stored procedure called column properties. So this stored procedure will gather some statistics about all the columns in the input table, and will give us some statistical summary. For example, it is giving a list of the columns that are present in the data set, and what is the type of data in the columns, and what percentage of the values are missing, and also number of missing values. So it gives us this data, which is very helpful when doing exploratory data analysis. And also, using the data available in DB2, we can create different plots. So I'm just skipping ahead. So for example, here we're looking into the distribution of values in the S column. Also, we have a stored procedure in DB2, which we can use for checking if the data is skewed or this is a normal. Is it a normal distribution? Then next, we can do a train test split using DB2's split data stored procedure, where you can specify the fraction of the data that goes into the training subset and the fraction of the data that will be part of the test subset. And so the raw data that are available in a database table is usually not suitable for a machine learning algorithm. It needs to go through different transformation and cleanup step. So in DB2, we provide impute data stored procedure. With this stored procedure, you can replace any missing values, and we provide different methods for imputing the missing values. So if it's a numerical column such as S and there are some missing cells, so we can impute with mean, we can impute with median or the most frequent value as well. Then after that, let's see. Yeah, then we also provide both a standardization and a normalization stored procedures. So you can do, you can bring all the numerical columns into a single scale, which is required for many machine learning algorithms, which does not deal with the numerical values in different scale. And then next, the data is prepared, data is clean, it's ready for doing some machine learning. So you can call linear regression stored procedure. You can give the model a name. You can provide the input table name here. This table has all the data, the clean version of the data from the previous steps. Then you specify what is your target column, like we are, or the model will be predicting the purchase amount. So this is the target column. Then we are specifying the list of input columns here that we want to use as the features of the model. Then once this is executed, and if the data is in, as mentioned before, if the data is not a single data partition, it's distributed, then this model will divide the task and learn a model across different data partitions. So once the model has been created, it is automatically deployed. So as you can see that one of the major challenges with the model deployment, as I mentioned, that finding a host and finding a way to deploy that model, as I mentioned, this is one of the big challenges in a data science project. So here we take care of that automatically. You train a model in DB2 and that model automatically gets deployed inside the database. Now, once the model has been created, now we can also validate this model. So let me show you. Yeah, so here we will be evaluating this model using the test data set. So remember that initially we have made two splits of the data set. 80% of the data was created, was used for training of the model, and 20% of the data was set aside. We set aside for evaluating the model. That's what we're using now, and then we see the model performance. So essentially, all this, the entire workflow is entirely executed inside the database, which does not require the movement of the data, and which will also help you which will also give you the speed because there is no network latency, there is no data movement. It will help you with IT cost savings, because now you don't need another system for your ML development, a second system for your ML deployment, and because you get more value out of your investment on the IT infrastructure for database. And also this simplifies the architecture, because your model is built, trained, deployed, scored all in a single system, or in a single setup, if it's a distributed database. Then also it simplifies the governance, because you are not making multiple copies of the data. So you can actually leverage your data governance capabilities that you have set up inside the database. So now let's summarize that we highlighted different challenges. There are challenges like there could be talent gap. Let's say you have a smart programmer who may not be familiar with the machine learning stack, but they know SQL, so they can easily leverage the stored procedures inside the database for building a machine learning model in the database with some basic understanding. We can also deal with the regulated data, because the data is not copied to a separate system if you are building DB2 native ML models. We are also addressing the data transfer cost by eliminating the data transfer need if you are building model inside the database. The infrastructure, you can reuse the infrastructure of the database system. Inference performance is also improved, as I have shown that we are able to achieve up to 5 times performance acceleration when we brought the model to the database system. Integration of ML is also simplified, because now for a downstream application to use predictions from ML model, all they need to do is send some SQL query statement to DB2, which will use the ML model that are deployed on or created inside the database or deployed on the database platform. So this integration of ML is much easier now. So this slide provides you a list of the demos that we have on the defined machine learning capabilities in DB2. These demos are short, about 5 to 7 minutes in length, and also all the notebooks that are presented in each of these demos and the instruction how we can try this on your own are available in this link. And also we have the DB2 Knowledge Center. So that's pretty much all I wanted to cover, and if you have any questions, I'll be happy to answer.
Okay, I'm looking at the queue, and it doesn't seem we have any questions today. That sometimes happens with a technical topic like this, but it does mean that I think people appreciated the information. But let me take back control here and make myself a presenter so I can just wrap up the show today. And there we go. And the next thing I need to do is to advance one slide. Did that. And ask our final polling question, which is, hide. Gotta dress this guy up and close. Teach him something to do. There we go. Did you learn anything today? And we'd like to have people answer that question and let people vote. And as I say, I'll get this replay blog up hopefully in not too long, and you'll be able to run your own demo and stuff like that. That's always exciting when people get a chance to do that. That's great, Shake. Let me close that and share the results. And it said 100% of our studio audience learned something today, which is always a fantastic thing to see. It does mean that we've hit the mark with what our audience likes to have, and that's just fantastic. So with that, I think it's, I'd like to thank you once again, Shake, for doing a great job on this topic. certainly machine learning and that, and it's coming along and everybody should be looking at it. And with that in mind, I will cue the music. Thank you again. Continue thanking you. Wishing everybody a great weekend.
Thank you.
We move towards the holiday season. This is our last show for 2020. Merry Christmas, Happy New Year, Happy Holidays, or anything else that you're celebrating at this time of year based on your religion. Happy Hanukkah, Diwali, and all those other things. And we will see you on January 15th in the new year for Kerry Romanoff with DB2 11.5.5. Thanks again.
Thank you for having me.
Bye-bye, Shay. Thanks again.
Bye. Bye.